The second thing that you saw at the trial was that when data was introduced at the trial, which I and another witness introduced from whole genome sequencing, the intelligent design advocates just literally had nothing to say. We weren't asked questions in cross-examination. The other side never brought it up. They never argued against it. They just left it. Here's an example. Many of you may know that a few months ago, the genetic code of the chimpanzee was published. Therefore, we can compare our genome to these primate relatives. What do we find? I want to show you one striking finding that dates to about a year ago. You all know that evolution argues that we share a common ancestor with the great apes, the chimpanzee, the gorilla, and the orangutan. Well, if that's true, there should be genetic similarities, and in fact there are. But there's something that's really interesting and has the potential, if it were true, to contradict evolutionary common ancestry. And that is, we have 2 fewer chromosomes than the other great apes. We have 46, they all have 48. That's very interesting. Now, what does that actually mean? Well, first of all, the 46 chromosomes that we have, you got 23 from mom and 23 from dad. So it's actually 23 pairs. These guys have 24 from each parent, so they have 24 pairs. So everybody in this room is missing a pair of chromosomes. Now, where did it go? Could it have gotten lost in our lineage? If it got lost, if a whole primate chromosome was lost, that would be lethal. So there's only 2 possibilities. And that is, if these guys really share a common ancestor, that ancestor either had 48 chromosomes or 46. Now, if it had 48, 24 pairs, which is probably true, because 3 out of 4 have 48 chromosomes, what must have happened is that 1 pair of chromosomes must have gotten fused. So we should be able to look at our genome and discover that 1 of our chromosomes resulted from the fusion of 2 primate chromosomes. So we should be able to look around our genome. And you know what? If we don't find it, evolution is wrong. We don't share a common ancestor. So how would we find it? Well, biologists in the room will know that chromosomes have nifty little markers. They have markers called centromeres, which are DNA sequences that are used to separate them during mitosis, and they have cool little DNA sequences on the end called telomeres. What would happen if a pair of chromosomes got fused? Well, what would happen is the fusion would put telomeres where they don't belong, in the center of the chromosome, and the resulting fused chromosome should actually have 2 centromeres. One of them might become inactivated, but nonetheless it should still be there. So we can scan our genome, and you know what? If we don't find that chromosome, evolution's in trouble. Well, guess what? It's chromosome number 2. Our chromosome number 2 was formed by the fusion of 2 primate chromosomes. This is the paper from Nature a little more than a year ago. And I put up a little of the paper. I'm sorry it's technical, but look at what it says. Chromosome 2 is unique to our lineage. It emerged as a result of the head-to-head fusion of 2 chromosomes that remain separate in other primates. Those of you who have not kept up with how much we know about the genome should pay attention to this, because you'll be amazed at how precisely we can look at things. The precise fusion site has been located at base number 114,455,823 to 114,455,838. In other words, within 15 bases. And you'll notice multiple subtelomeric duplications, the telomeres that don't belong, and lo and behold, the centromere that is inactivated corresponds to chimp chromosome 13. It's there, it's testable, it confirms the prediction of evolution. How would intelligent design explain this? Only one way, by shrugging and saying, that's the way the designer made it. No reason, no rhyme.